So as much fun as making things is, we all know that destroying things is often way more fun. So step aside, Michael Bay. In this Blender tutorial, you're going to be learning 3 unique, easy ways to animate destruction in Blender. The coolest thing is, we're not using any paid add-ons. Everything we're doing today can be done by you for free at home. And a big thanks to Camino for sponsoring this video. Their custom-built, water-cooled workstations are beyond incredible. Learn more about Camino and their Grando RM featuring 4 RTX 3090s water-cooled later on in the video, and check them out with the link in the video description below. So our first destruction animation is going to be done using only Blender's internal tools, and that is going to be using particle systems and the explode modifier. So I'll be showing you how to do this on a TIE fighter, which I think is a good use case for this method of destruction. So I'm using this model here off of Sketchfab. I've modified it to work right inside of Blender. You can download this in the description if you want. For this method, you start by adding a particle system to your object, extend the lifetime for as long as you want the animation to go, and then adjust the start and end frames to when you want your model to start destructing to when it's completely destroyed. This has to happen pretty fast to be semi-realistic, so I'm going with 15 and 18. Basically, it's going to take 3 frames for everything to be destroyed into particles. So jumping into your modifier tab, add in the explode modifier. This method works by taking the faces of your mesh and transforming them into particles, and then you can interact with those particles with force fields and objects and stuff, so it's pretty cool. Choosing cut edges will give you more of a shard look that looks better for destruction, and you can make these particles a little bit smarter by going to the particle system tab, checking rotation, and then also checking dynamic. Then in the physics tab, you can choose multiply mass with size and increase the mass to something larger. 3 works in this example. Then under viewport display, you can hide the particles by choosing none. So now that your model is destroyed into particles, you can do some cool things like using force fields to control these. Here I added in a turbulence modifier, gave it a strength of something big, and you can see how it just rips the model apart now, sending it in every which direction, which might work well for a space explosion. You can also add objects to interact with this. For example, I'll add in a plane for a floor here, and under the physics, just choose collision, give it a dampening of 5 and a friction of 5, and then add a little bit of randomization to both of these values as well for a little bit more realism. And you can see with that, the particles are now interacting with another object. You can do the same thing with animated objects if you want to have a Suzanne head, for example, rip into the TIE fighter. So here I just added the same physics collisions to that Suzanne model. I enabled automatic keyframing, added a keyframe on frame 1, jumped to frame 30, and added another keyframe. Now you can see that Suzanne head interacting with the particles and ripping through that TIE fighter like it's butter. It's not always the most realistic, but it's a super easy method to get quick results exploding things in Blender. The second way you can animate destruction in Blender is using the cell fracture add-on and rigid body physics. I'm rendering all of these animations on the Grando RM from Camino. Camino builds custom water-cooled professional killer workstations. And by killer, I mean this thing destroys benchmarks. The Grando RM I have here features a water-cooled 32-core Threadripper CPU along with 4 water-cooled RTX 3090s. Blender works extremely well with extra GPU power, so single frames in these animations were rendered in just seconds, and the full HD rendered animations finished in just around 25 minutes. Learn more about Camino and their Grando RM water-cooled workstations with the first link in the video description. For this example, I have a new 3D scanned rock model that you'll be learning more about in the near future, so stay tuned for that. And you guessed it, we're going to be destroying this rock. So for this one, we have to start by enabling the cell fracture add-on in the preferences. Once you check that box, it's enabled. And if you go to your object dropdown, quick effects, choose cell fracture. Here we have a lot of settings, but it's actually quite simple. The source limit determines how many broken parts of the rock we're going to have. Noise adds a little bit more randomness. I found a low value of this works. You can't go too high with it though. And then the recursive shatter options allows you to take shards that are already broken and break them into even more small pieces. You can go a little bit with this. I like to go about 2, but again, too much with the rigid body physics gets pretty messy. There's a few other options here for determining which shards get broken into smaller pieces. You can play around with these, making it random or just breaking the big shards smaller, but I actually found small to be more realistic. And then the last setting that you want to pay attention to is the material setting here. So if you look at the object, I actually have 2 materials, and this is because I want a material for the inside of those shards as well. And if you set your settings to be material 1, that will mean that all the materials on the inside of this object, once it's shattered, will be using the second material in your material tray. So with that said, go ahead and click OK. Now you can see that object is broken into a bunch of smaller shard objects, and your original object is still there. You're going to want to make sure you grab this and move it out of the way, otherwise it will be messing up your animation. Now go ahead and hit B to box select all these shards inside of that rock. Go Object down to Rigid Body and choose Add Active. Then you can go back to Object again, down to rigid body again and choose calculate mass with them all selected still. Here you have a bunch of different presets for calculating different weights of different objects, and for this one I'm going to choose stone crushed. Now you can see if you jump to the physics settings, all of these objects have a different unique mass depending on the size of the shard. This adds a lot of realism to your animations. Grab your floor plan, then go object, rigid body, and choose add passive. And that's the basic settings for a rigid body animation. And as you can see, once it's destroyed, the inside of this rock has a different material. And this is just a basic rock PBR material with the mapping set to generated instead of UV. This is really the only way to avoid too much stretching on the textures on the inside of those shards easily. But now you can take these rigid bodies even further by using a few constraints. So select all of your shards again, go object, rigid body, and this time choose connect. To keep it organized, I like to select all of the rock shards and constraints and then hit M to move them to a new collection that I'll name something like rock. Now if you shift grab one of your constraints to make it the active constraint and jump to your physics tab, you can see that we have a few settings here for the constraints. Starting with breakable, go ahead and check that on and then right click copy to selected. This will add the same setting change to all of those rigid body constraints. Same with the threshold, select them all, change the threshold to something like 25 and then right click that value and choose copy to selected. Now all of these constraints have breakable and a threshold of 25 set to them, and so if you play back the simulation you can see it's quite a bit more realistic as some of the shards hold together and some of them break now. Then just playing around with this threshold value will determine how likely your rock is to break when it collides with something. As you can see, a value of 55 breaks a pretty decent amount still, but a value of 100 actually holds together more or less. Another great physics use case for the self-fracture add-on is something like a log or beam like I have here. If you want to have a little bit more control on how your object or log in this case is shattered, you can use the annotation tool. You can select it on your toolbar or you can hold down D and draw some lines across your object here. Now if you go object, quick effects and choose self-fracture, you can shift select annotation tool. And now when you process that, you can see that all of the shards are focused around those lines that we drew on our object. And now you can even affect the self-fracture even more, but this time along the X, Y, and Z scale, change the Z value all the way down to something small, like a 0.1. And that will make these shards very long and skinny along the Z axis, as you can see here, which look a lot more like shards of wood if you're going to shatter this log, as of course, as you might expect, I went ahead and did. Now you might have realized the default cube almost made it throughout the entire video without getting destroyed, so we have to take care of that right now. For our third method of destruction inside of Blender, we're going to be using the molecular free add-on. First, we'll install the molecular add-on by going into your preferences and making sure you've downloaded the molecular script. I'll leave the GitHub link in the video description where you can download the script for your specific computer. Then just click install in the Blender add-ons and choose the molecular zip file. And if you switch from all to user installed add-ons, make sure you have the molecular script enabled with that little checkbox there. So to bring up your molecular script add-ons, you're just going to hit N on your keyboard to bring up your properties tab. And along the sidebar, we have a few different tabs. Just select the molecular plus option here. Right off the bat with the cube selected, you can choose 3D grid. And if I hit Z to go into wireframe mode, you can see this adds a whole bunch of particles in a grid inside that cube. You can go ahead and add a floor plane, choose the collider option on the plane within the add-on here. And then if you played back your simulation, you can see all of those particles would pour out and fall onto the plane, but something's different because unlike Blender's normal particles, these are actually piling up on top of each other because they're interacting with each other. And that's one of the ways where the molecular script is super cool. We can make it even smarter if we jump to our physics tab with the cube selected. You can see we have some settings for the molecular add-on. Starting with the link setting, go ahead and choose link at birth, then choose calculate particles weight by density and give it the preset of sand, which I found worked pretty well. Just by changing those two settings, if you were to move your cube up into the air, free the bake, and then calculate the simulation again, you can see that it now bounces around like a chunk of jello because all those particles are linked together. But if we wanted to break apart, because this video is about destruction, you can take the broken value here at the bottom and give it something smaller like a 0.1. A little bit of random broken also helps add some realism to the simulation. Now you can see it's breaking with only certain parts of the particles still holding together depending on where the velocity is hitting that cube. In a very realistic, satisfying fashion, I might add. Now to render these particles, you can just add in another cube, select your particle cube, and under the particle settings, first change the viewport display to not show the emitter, so uncheck show emitter, and then under the render settings, also uncheck show emitter. Then under the render as, change it from halo over to object, and for that object, choose the second cube that we just added into the scene. Now if we recalculate our simulation, you can see it's made up of a bunch of smaller cubes. This is pretty cool, but I still don't feel like we've caused the default cube enough pain yet. So go ahead and add in another cube. This will be our destruction cube. In the molecular settings, set it as the collider. Enable automatic keyframing, and on frame 1, give it a keyframe. On frame 50, move it to swipe through the cube and add in a second keyframe. And then when you calculate the simulation, you can see here that I missed. It's a little embarrassing. So go ahead and move those 2 keyframes down a little bit, and you can see that now it collides with the cube when we calculate the simulation, and it looks really sick. And you might notice that these cubes aren't rotating, and they're keeping their exact same rotation the whole time, which doesn't look very cool. So just like we did for the first method of destroying things, if you jump to your particle settings and turn on rotation and enable dynamic, then calculate your simulation again, you'll see that those cubes are now rotating, and when they get collided with, they go spinning and fly off in a very satisfying destruction-y type of a way. Now you can change the quality of this by selecting your particle cube and changing the size. I found going down to a 0.05 was about as far as I wanted to push it. Then you just free the bakes and click 3D grid again, and as you can see, it added about twice as many cubes to our simulation. You can adjust the step setting here as well in the add-on. Going smaller will calculate the physics faster but lose a little bit of accuracy. So this is up to you. I'm going to go with a value of 12. And voila, with the magic of editing, here is our finished simulation, and it's looking very dope. So go ahead and destroy as many default cubes now as you like. Now, as a bonus tip, you can use this method in combination with our second method, having the molecular particles as a ground plane underneath a cell-fractured surface. And when you set up an object as a collider for the molecular add-on as well as the rigid body physics, you can get some pretty cool results bursting through both of these layers combined. So I hope you guys have learned a few new ways to destroy things inside of Blender. Hope you enjoyed this video. If you did, let me know with a like on the video, and if you had a question, you can leave a comment below. Thanks again to Camino for sponsoring this video. Check out their incredibly cool, pun intended, custom water-cooled workstations with the link in the video description. That'll do it for me, guys, and I'll see you soon in another video. Bye-bye!